Hello, welcome. The problem reads locate the centroid x bar of the area as well as y bar of the area. The problem is coming from the engineering mechanics statics textbook, 13th edition by R.C. Hibbeler. Right, we have been asked to find the centroid. Let's briefly talk about what centroids are. Centroid is basically the geometric center, right? Geometric center. So this can be the geometric center of a line. It can be a geometric center of an area, like in this particular case. It can be a geometric center of a volume. Right. So we have what is called centroid of a line. We have also what is called centroid of an area. We also have what is called centroid of a volume, right? And then when density rho is uniform, when density rho is uniform, coincides, centroid coincides, it coincides with the center of mass, right? The center of mass. And when gravity, acceleration due to gravity is uniform, centroid coincides with the center of gravity. So this is in a case where both uh, density and the acceleration due to gravity is uniform, then we expect centroid to coincide with the center of gravity. Okay, so let's go and dive into the problem and start solving. So to start with, we need to cut a small strip, if you want to call it that way. We're going to cut in this direction. Let's cut it. You can cut anywhere. You don't have to cut at the middle like I'm doing it. I mean, you can cut even there. Okay, it doesn't matter where you are cutting, right? So let's cut here. Just a small piece. This is where we're going to drive everything. So this thickness of this, imagine, is a very small piece. We are calling the x, and then it's been governed, or its height. This height is y. Okay, being governed by this function. Okay, and then its centroid along the y direction. The centroid for this small piece, we are calling it y curled, is just equal to y divided by 2. And this centroid along the x direction, we are calling it x curled, is equal to x. And this area, the small strip, dA, is going to be equal to y, okay, times dx. All right. So we have everything. So what we need to do now is to start working. So let's start with x bar. X bar is going to be equal to integral. These are moments of area. X curled dA divided by total area dA. Okay. And therefore, let's start replacing. What is x curled? Our x curled is the centroidal axis for this small strip, which is just x. As our dA, it is y dx, and we are integrating with respect to x. Therefore, our integration constants is from 0 to a pi, right? So divided by the total area 0 from a pi, so y dx. So x bar is going to be equal to, let's start replacing. We replace the y, this y, seeing this y here, this y here, we need to replace it there, here, right? And also we do the same there. We do the same um, there. Okay. Okay. So if we did that, then we are going to have the following: x bar 0 to a pi x times what is our equation? That is a sine x over a dx divided by integral from a to pi just a sine x over a dx. Right. So what do we do? We need to integrate these particular functions. The top part, this top part here, we can use. This is an integral of product of two functions, so we can integrate by parts. But if you have a table of formulas in your test and in the exam, I advise you to use those integrals in your table, so that you don't waste time in integrating. But if those things are not there, then you need to do it yourself. So let's start with the top here. We are going to use integration by parts. We're going to use integration by part. Let me use this space here. I use this space. Okay. So say integration by parts, integral of u v dx is equal to u v minus integral of v du dx. So we need to choose u, and the criteria for choosing u from this expression. Which expression is that? Integral from a 0 to a pi. X is one function, then we have another function which is a sine x over a dx. So what's the criteria for choosing u? Because these are two functions, this is just a way of integrating called integration by parts. So we need to choose u should be you should give us the simplest derivative, right? That's normally the rule, right? So therefore our u in this particular case, our u, we are going to choose u as x, so that our du dx is just going to be equal to 1. Okay, and therefore our dv over dx is going to be equal to a sine x over a, and therefore our v, if we integrated this, this gives us a minus a squared. We know when you integrate sign, right? A squared as cos x over a. All right. Of course, we are supposed to say plus c a constant, but we don't need it in this case. We can forget about it. Okay. All right. So there we go. So once we've done that, then we need to now replace these particular values. Let's replace them. Let's start working. We've done this by parts, therefore we can write this as integral. We are just dealing with the top now. Integral from 0 to a pi of x a sine x over a dx is equal to uv. What's our u? Our u we said is just x, and what's our v? Our v we said is minus a, so we can put our a there, just writing everything. Say minus a multiplying there a squared cos x over a, right? Of course. Mm-hmm. And then we have minus integral from 0 to a pi of v. What is our v? Our v again is minus a squared cos x over a, and then times du dx. What's our du dx? Is just a 1. Okay, this is as good as nothing, right? So once we have that, then we can simplify it further. You can say so instead of writing it like this, okay, it's fine. Therefore, this function becomes equal to a sine x over a dx will be equal to minus a squared x cos x over a. This becomes a plus, minus minus plus, then we integrate that. We integrate, this becomes, if we did the integration of this part here, this becomes sine, it becomes sine, there's an a there, there's an a, once we integrate a will come up, so a by a squared, so it will multiply here, we'll have a cubed, right? A cubed, and then we'll have sine x over a. Then now we are saying our integration limits, we need to feed in these values, right? Great. So our integration from a to pi of x, a sine x over a dx is going to be equal to, let's start plugging in. If we plugged in a pi in here, what do we have? We have a minus what? A pi into cos, in there a and a cancels, we'll have a minus 1. Cos 180 is minus 1, and the minus becomes positive, right? So this becomes a cubed pi, okay, and then we plug in again a pi in sine. A and a cancel, so sine 180 is 0, so nothing in there. 0, the first part is 0, the first part is 0, so this is the final solution, okay, for this top part. Then the bottom part, what do we have? The bottom part, we have integral from a to pi, a pi, a sine x over a dx. And what does this one give us? Of course, this one is quite easy. So if we integrate this one, we're going to have something like this. This becomes a squared. Integrating this, we'll have a minus, right? Of course, we are going to have a minus, because sine, integration of sine is minus cos, so minus a will go up, that one, so a squared, it will multiply, then cos x over a. Great. And then we are integrating over these constants. So what does this give us? We plug in the a pi in there. This gives us a positive value, which is just a does this one give us? A into cos 180, this just becomes a squared, okay, and then 0 in there, minus minus, it becomes a plus, also a squared, which is equal to 2a squared. Therefore, the total area dA is equal to 2a squared. We need to remember this. Alright, I'll write it here. So integral of dA, because we come and use it later on, is 2a squared. Great. So now let's finish off our x bar. Our x bar is equal to integral of x squared, like we are doing it there, divided by a dA. We found this as equal to a cubed pi divided by 2a squared. This is going to be equal to a pi over 2. And for sure, because there is symmetry about this axis, we expect that, right? About that center. All right, so we found one answer, which is, let me write it somewhere here. X bar is equal to a pi divided by 2. Okay, because this and this cause will just remain with a there, right? So a pi over 2. Great. Let's go to our next part. Let's rub this stuff. All right. What is our next part? This we can rub. Okay, there we go. So our next part is y. Right. Of course. So we have y is equal to integral from 0 to, no, of course we're going to use the same index direction, so I'll write this in advance. Y cubed dA divided by dA. dA, we already know it, so our y is going to be equal to, our y will be equal to, our y will be equal to 0 to a pi. This y, centroid in the y direction, is y over 2. Our dA is just y dx divided by our total area, which is just a 2a squared. So let's find the top part quickly. So integral from 0 to a pi, this becomes y squared over 2 dx. Okay, this therefore is going to be equal to integral from 0 to a pi y squared. Let's push in this equation, this one here, this one, let's place it in there. If we do so, we're going to have a squared sine squared x over a divided by 2, which we can factor out. There is a 1 over 2, so dx. All right, so when we reach at this stage, of course we can again factor out the a squared. We can say integral from a pi a squared over 2, then we only have sine 2 squared, sine squared dx over a dx. So we can use identities. To rewrite sine squared sine squared x over a. So we know that sine squared x over a, okay, this one there, plus cos squared x over a is equal to 1. Okay, and then we can write this as sine squared x over a is equal to 1 minus cos squared x over a, right? We also know that cos 2x over a is also equal to cos squared x over a minus sine squared x over a. And we can write this in terms of cos. We can say cos squared x over a is equal to cos 2x over a plus sine squared x over a. So we can replace this one here, right? Can replace this here, and when we do so, then we are going to have this expression. We'll have this expression. If we do so, we are going to have the following expression. Our sine squared x over a will therefore be equal to 1 over 2 minus 1 over 2 cos 2 x over a. Okay. Okay. Is that fine? Yes, it's fine. So this expression, let's now feed it in our integral. So integral of this integral a squared over 2 0 to a pi sine squared x over a dx is therefore equal to 1 over 2 integral 0 to a pi a squared over 2 1 over 2 minus 1 over 2 cos 2x over a. Okay, right, and dx, right? So there we go, we have an expression like that. We have an expression like that, and then what we just need to do now is to work out this particular problem. So let's integrate it. So if we integrated it, this becomes okay, we can factor out the 2 again there, so that we have a squared over 4, and then here if we did the integration constant, we have an x minus, did an integration there, we are going to have a, okay, sine 2x sine 2x over a, integrating from 0 to, yeah. So let's feed in these constants in there. We have a squared over 4. Okay, so we're going to have a pi there minus what do we have? Just 1 minute. I need to increase this because I'll be subtracting if need be. So this is a pi minus, when we plug in the part a pi in there, a and a cancels, then we have 2 pi. Sine of 2 pi is a 0. Sine 2 pi is 0, right? Alright, so minus 0 in there is 0, 0 in there it is just 0. So this is just the final solution, right? This is the final solution here. So this is just like that. And therefore, this becomes equal to a cubed pi divided by 4. Okay, so found the top part. So now let's evaluate this. Y bar is therefore equal to integral from 0 to a pi. Can even just get rid of this. Okay, integral of y cubed dA divided by dA, the integral of dA. This gives us a cubed pi divided by 4 over 2a squared. Okay, 1 there, 1 cancels, we have just an a, so this therefore gives us, this becomes 4 and 2 is an 8, so this is a pi divided by 8. Alright, so let's write the summary of the solution. We write the summary of the solution. X bar is going to be equal to a pi divided by, maybe I start with, since pi is known, I say pi, then a divided by 2, and then y bar is going to be equal to pi a divided by 8. All right, this is about it. This is about it for this particular problem. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my video. Bye bye, and see you in my next screencast.